Hello everyone. The headline of today's lesson is composition of functions. Definition. A new function can be defined with the use of two functions, f of x and g of x. We can generate 6 new functions from f of x and g of x and more. The first one, f plus g of x, the addition of f and g, f minus g of x, subtraction of g and x. Of course, this is equal to g plus f of x, since the addition is commutative operation, but f minus g not equal to g minus f because subtraction is not commutative operation. F times g equal to g times f, since multiplication is commutative operation. F over g, here g not equal to 0, and of course not equal to g over f. F og, the most important two composite function is 5 and 6. F og, f of x equal to f of g of x equal to f of g of x, and g of OF equal to g of f of x. Let us solve example. If f of x equal 1 over x and g of x equal square root x plus 2, find f plus g of x. F plus g, I'll add f to g. F is 1 over and 1 over x plus g of x is square root x plus 2. That's it. F minus g, subtract g from f, 1 over x minus square root x plus 2. F dot g, f times g, 1 over x times square root x plus 2 equal to square root x plus 2 over x. F over g is equal to 1 over x over square root x plus 2 equal to 1 over x square root x plus 2. F O G, it is f of g of x equal to f of g of x is square root x plus 2. Then in the function f of x, change the variable x with the variable square root x plus 2. It will be 1 over square root x plus 2. G of is g of f of x equal to g. Change f of x with 1 over x equal to, in the function of g, change the variable x with 1 over x. It will be square root 1 over x plus 2. Example, find f of g and g of f where f of x equal x squared and g of x equal square root x. F of g of x, its definition is f of g of x equal to f. G of x is square root x. Then f of square root x, in the function f, change x with square root x. It will be square root x power 2 equal to x. G of x, its definition is g of f of x equal to g of f of x is square root is x power 2 equal to, in the function g, change the variable x with x power 2, then it will be square root x power 2 equal to absolute value x and not x. Note the statement square root x power 2 equal square root x all power 2, here square root x power 2, here square root x all power 2 is not generally true for all real number. For negative number is not true, for positive number is true. For example, if x equal negative 4, then square root negative 4 square not equal to square root negative 4 all square, because negative 4 square is 16. Square root 16 is 4. 4 not equal to square root negative 4 is 2 square root negative 1 all power 2. This equal to 4 negative 4. Since 2 power 2 4 and square root negative 1 is negative 1, negative 1 times 4 negative 4, then 4 is not equal to negative 4. Example, use the graph to find these statements. The red function is f of x and the blue function is g of x. Find f o g of 3. F o g of 3 is equal to f of g of 3. G of 3, this is g and this is 3. G of 3 is negative 1. This is 3 negative 1. G of 3 is negative 1, then I need f of negative 1. F of negative 1, this is negative 1, this is f of negative 1 equal to 4. G of f of 2 equal to G of f of 2 is 1. Then I want G of 1. G of 1 is negative 2. G of f of 5. G of f of 5, this is 5, this is f of 5, is negative 5. G of negative 5, as you see, the domain of G is from negative 4 to 4. Then negative 5 is not in the domain of G, then it is undefined. G o f o g of negative 3 equal to f of g of negative 3 equal to f of g of negative 3 is 2, negative 2, negative 2. F of negative 2 is 3. G of f of negative 1, it is g of f of negative 1 equal to g of f of negative 1 is 4. Then g of 4 is 2. F of g of negative 1, g of negative 1 is negative 4. F of negative 4, as you see, the domain of f is start from negative 3 to 5, then negative 4 is not in the domain, then it is undefined. Example, find f o g o h of x, where f of x equals square root x, g of x equals 3x, and h of x equals x minus 2. F o g o h of x, its definition is f of g of h of x equal to f of g of h of x, x minus 2, equal to f of g of x minus 2, it is 3 times x minus 2, equal to f of 3x minus 6, equal to f of 3x minus 6 is square root 3x minus 6. Domain and range of composite function. The domain of f of g of x is either equal to domain of g of x or subset of it, and the domain of g circle f of x is either equal to domain of f of x or subset of it. Example, find the domain of the function f of g of x if f of x equal 3 over x and g of x equal to 2 cosine pi x. First, I need to find f of g of x equal to f of g of x equal to f of g of x 2 cosine pi x equal to. In the function f, replace x with 2 cosine pi x, then it will be 3 over 2 cosine pi x. To find the domain of this function, the denominator should not be 0. To find the value, make 2 cosine pi x 0, I set pi x equal to pi over 2 plus k pi. The value make cosine 0. Then I find x. Divide both sides by pi, x equal to 1 over 2 plus k. Then the domain is all real number except those equal 1/2 plus k. K is an integer number. Then the domain of f circle G equal to R except x, where x equal to 1/2 plus k, k belong to I. Example, find domain of G circle f of x if f of x equal square root 4 minus 2x, g of x equal 1 over 2x. G circle f of x equal to g of f of x equal to g of f of x is square root 4 minus 2x equal to. In the function g, replace x with the square root 4 minus 2x is 1 over 2 square root 4 minus 2x. Since the square root is in the denominator, to find the domain, I set 4 minus 2x greater than 0, not greater than or equal, and solve to find x. Then 4 greater than 2x, then 4 divide 2, 2 greater than x, or x less than 2, then the domain of G circle F equal to negative infinity to 2 open interval. Example, if f of x equals square root x and g of x equal 1 over x minus 2, which of the following is not in the domain of f or g? First, I need to find f of g of x equal to f of g of x equal to f of g of x 1 over x minus 2 equal to f of 1 over x minus 2 is square root 1 over x minus 2. The domain of this function is, since the square root is in the denominator, then x minus 2 should be greater than 0, then x greater than 2, then the domain of f circle G equal to 2 to infinity, open interval to positive infinity. Then 3 is in the domain, 5 is in the domain, 9 is in the domain, 1 is not in the domain. Example, f of x equal square root x, g of x equal 3 minus x, find domain of f plus g. Let me find f plus g of x equal to f plus g of x. I have a function of addition of two square roots. Find the domain of every square root. Separate. The domain of square root x is 0 to positive infinity, as you know. And the domain of 3 minus x, set 3 minus x greater than or equal 0, then 3 greater than or equal x, or x less than or equal to 3, then the domain of 3 minus x is negative infinity to 3. Union, or intersection, negative infinity to 3. To find the intersection of these two intervals, this is negative infinity, this is 0, this is 3, this is positive infinity. The first interval 0 to infinity, positive infinity, these numbers, and the second interval negative infinity to 0, these intervals, these numbers. The intersection is from 0 to 3, with 0 and with 3, since 3 is in the second interval and 0 is in the first interval. Example, find three functions f, g, and h so that k equal f or g or h and k of x equals square root 2x minus 2. This question has infinity solution. It's you need to find a conformable function that make k of x equal square root 2x minus 2 equal f or g of h. I'll give you two of these infinity solution. If we set f equal to square root x, since I have square root here, and g equal to, I subtract 2 from variable x minus 2, and h is, h equal to multiply the variable by 2 to x. Now, if I find f or g of h of x, it's equal to f of g of h of x equal to f of g of h of x is 2x equal to f of g of 2x is replace x with 2x is 2x minus 2. F of 2x minus 2 replace x with f 2x minus 2, it will be square root 2x minus 2 equal to k of x. Now, if I set f equal also square root x, but I change g to 4x minus 2, sorry, for x over 2 and give h as 4x, then f or g o h of x equal to f of g of h of x equal to f of g of h for x equal to f of g of 4x, replace x with 4x. 4x over 2 is 2x minus 2. Then f of 2x minus 2 is also square root 2x minus 2 equal to k. And just like this. Example, it's a word problem example. People is dropped into a still pond, causing ripples in the form of concentric circles. The radius of the outer circle increases according to the model r equals 0.6 t, where t is the time in seconds after the pebble strikes the water, and r is the radius of the circle in feet. The area of the circle is given by a equal to pi r squared. Find a or of t. What is the area of the outer circle after 6 seconds? Let me solve this question here. A or r of t equal to a of r of t equal to a of r of t is 0.6 t. A of 0.6 of t is pi 0.6 t squared equal to pi or 0.36 pi t squared. The second needed, find a or r, what is the area of the outer circle after 6 seconds. Then I need to find a or r of 6 equal to 0.36 times 6 power 2 times pi 3.14 equal to 0.36 times 36 times 3.14. You can find the result from calculator. Example, find the domain of the function g of x if f of x equal x power 2 minus 3x plus 2 and g of x equal 1 over x. First, I need to find g of f of x equal to g of f of x equal to g of f of x power 2 minus 3x plus 2 equal to 1 over x power 2 minus 3x plus 2. Fraction function, denominator should not be 0. Then I'll analyze the denominator by, or I'll find it here. I'll analyze the denominator by experiment x minus 2, x, to find the values that make the denominator 0. X minus 1 times x minus 2 equals 0. Either x equal to 2 or x equal to 1. This value make the denominator 0. Then I'll remove it from real number. Then the domain of G circle F equal to all real number except 1 and 2.